Here are some different ways of writing 6,500. We can write it equal as 6.5 thousand, 6.5 times 1,000, actually writing out the 1,000 as a number, and then also 6.5 times 10 to the third if we write 1,000 as a base of 10, which means that 6,500 equals 6.5 times 10 to the third if we go from where we started to where we ended up. 6,500 is standard form of a number, and 6.5 times 10 to the third would be scientific notation. These are two different ways of writing the same number. 6.5 times 10 to the third isn't a lot more convenient than 6,500. You're still writing the same amount of numbers here, it just looks a little different. But let's do the same thing now with 7,400,000,000. That's equal to 7.4 billion, which is equal to 7.4 times 1 billion, if we write out billion as a number, and also equal to 7.4 times 10 to the ninth if we write out 1 billion using our base of 10. So besides being shorter than 7,400,000,000, it is a lot easier to keep track of the zeros in scientific notation. We'll see that the math gets a lot easier as well. Scientific notation expresses numbers as the product of a coefficient and 10 raised to some power. That's the key, and that's the format. So here we have a coefficient. Now remember, a coefficient is a number used to multiply a variable and is a factor of a term. It's always written all the way to the left of a variable or before a base in scientific notation, as we see the format here. And your coefficient is always non-zero numbers. In scientific notation, more specifically, the coefficient is always greater than or equal to 1, but less than 10. So here, in this case, the number 3,780,000 is expressed in scientific notation. Now, there's an easy way to convert between standard form and scientific notation. You can follow these 4 steps every time. So here we're using the number 870,000. So first we're writing the number without the comma. We're going to place the decimal so that the first number will be less than 10 but greater than or equal to 1. So here we're going to place it between the 8 and the 7. We're going to count how many places we had to move the old decimal point. So when the old one was there, it was all the way to the right, and it was moved 5 times. And this is going to become the exponent of 10. So that's why there's an exponent of 5. And we drop all 4 unnecessary zeros to leave the 8.7 to give our scientific notation. Let's look at this and do 2 examples together. So first, let's express 284 million in scientific notation. First, we're going to write the number without the commas. So 284,000,000. We're then going to place the decimal so that the first number is less than 10 but greater than or equal to 1, and we're going to input our base of 10. So here we're going to place the decimal between the 2 and the 8 because that would give us 2.84. And now we need to count how many spaces we moved in order to put that decimal there. So here the old decimal used to be all the way to the right. So it had to move 1, 2, 3, 4, 5, 6, 7, 8 total places. So that will become the exponent of our base of 10. And now we're going to drop all the unnecessary zeros, making our coefficient 2.84 for scientific notation of 2.84 times 10 to the 8th. Another example, let's express 53,600 in scientific notation. Following the same steps, we'll start by writing the number without the comma, so 53600. We're then going to place a new decimal in between the 5 and the 3, making a number 5.36 because that's less than 10 but greater than or equal to 1. and we'll include our base of 10 to some exponent. Now that exponent comes from how many places we move the decimal. So it used to be all the way to the right. Now we're moving it 1, 2, 3, 4 total spots. So instead of a question mark, that exponent will become the 4 because that movement is your exponent of the 10. And if we drop the 2 unnecessary zeros, that would give us a coefficient of 5.36, making our answer 5.36 times 10 to the 4th as our scientific notation. And these were just 2 examples, but you can do these 4 steps for any number to convert from standard form to scientific notation.